Today we have a classic problem from MIT Integration B, which is a prestigious Integration B competition in the world. So we have this integral. First of all, it feels like we don't want this weird expression inside sine. Instead, we might want to substitute this as u and make it a bit simpler in look. Yeah. So let's substitute y equals to 1 by x. So that changes our limit from infinity to 0. 1 minus 1 by y sine of y, and then dx will be minus 1 by y squared dy. I'm sorry, it shouldn't have happened though. Fine. Okay, good. Minus 1 by y squared dy. Yeah, x equals to 1 by y, then dx equals to minus 1 by y squared dy. And now this minus will reverse the limits of integration. And we have 1 by y squared. Let us first take the LCM. Y minus sine y and 1 by y cube dy. It feels like we can simplify this sign expression if we use maths identity. So what's math identity? If you have integral from 0 to infinity, f of x, g of x dx, then maths identity tells us that this also equals to integral from 0 to infinity Laplace of f, Laplace inverse of g, and then the new world dy. This Laplace and Laplace inverse will take f and g to the world of y. Yeah, so these two are equal from math identity. So we can just take this to Laplace world, and we can just take it to Laplace inverse world, and then there we can do something since this one simplifies. Yeah. And for this one to Laplace inverse, we can change it to gamma of 3 by gamma of 3. Okay, so that will simplify a lot. Now for this one, let us bring it to new world of Laplace. This is power 1, so we will have gamma of 2 by z square, and this will be 1 by z square plus 1. Yeah. And this will be y square, and then 1 by gamma of not y square, the Laplace inverse will take it to world of g. So z square times 1 by gamma of 3 in the new world dz. Now if we just take LCM, this is z square plus 1, and then z square plus, this is just 1, z square plus 1 minus z square, that's 1 times z square times 1 by 2 dz. This cancels out, and we have 1 by 2 integral from 0 to infinity. And now it's a pretty easy expression to evaluate. Yeah, it was the magic of maths, that just changed this difficult expression to real simple expression. Now this is just tan inverse z in integral from 0 to infinity. At infinity this is pi by 2, at 0 this is 0, so the answer is pi by 4. Yeah, and we have solved the integral. The answer is pi by 4. And this problem was one of the best problem for invoking maths identity, and that's what helped us to solve the problem. Hope you enjoyed the solution. Thanks for watching. Look forward to seeing you in the next video. Be happy and healthy.